Yeah, good evening, online students. Meera, Shreyas, Rajeshwari, Subbalakshmi, Sashmin, and Priyasha.
Good evening, ma'am.
Good evening,
ma'am.
Good evening,
Good
ma'am.
evening. Good evening. And good evening, class. Good evening, all of you. Yeah. Yeah, let's begin. So we finished till here in the last class. Look at this question. 0 is the center of a circle of radius 5 centimeters. Oh, sorry. O is the center of the circle of radius 5 centimeters. At a distance of 5√5 centimeter from O, a point P is taken. At a distance of, okay, let's draw as we read, let's draw. My screen is visible, children. I've shared my screen.
Yes.
Is it visible? Okay. All right. So circle with center O. Radius is 5 centimeters at a distance of 5√5 centimeters from O. So there's a point P. So let's take a point P. This is the point P. The distance of this point P from O is 5√5 centimeters. That means OP, which means OP is 5√5 centimeters. OP. At a distance of 5√5 centimeters from O, a point P is taken, which means OP is 5√5 centimeters. Two tangents PQ and PR. Two tangents PQ and PR. PQ and PR are drawn to the circle. Find the area of the quadrilateral PQOR. So we have to join. We'll have to join OQ and OR. And the question is to find the area of the quadrilateral PQOR. Can you see the quadrilateral PQOR? PQ. Okay, what's the special name you would give the quadrilateral PQOR? What special name would you give to the quadrilateral PQOR?
Hypotenuse.
No. PQOR is a quadrilateral, correct? Is PQO? Yeah. Now the question is give a special name to this quadrilateral PQOR. Give a special name. Cyclic quadrilateral. Very good. Okay. Another name. Good. Cyclic quadrilateral. You're not well? Okay. Cyclic quadrilateral. Correct. Another name. It is a kite. PQOR is a kite. It's a kite because see this side is equal to this side and this side is equal to this side. Okay, a kite is a quadrilateral in which both the pairs of adjacent sides are equal. Adjacent sides are equal, not opposite sides, adjacent sides. So this side is equal to this side and this side is equal to this side. Adjacent sides are equal. This is equal to this. The adjacent sides are equal. Opposite sides are not parallel. Opposite sides are not parallel. See, when you classify quadrilaterals, classification of quadrilaterals, okay? All right. A quadrilateral in which no pair of opposite sides is parallel is a kite. A kite is a quadrilateral in which no pair of opposite sides is parallel. One second, children. So a quadrilateral in which no pair of opposite sides is parallel is a kite. One pair of opposite sides parallel is a trapezium. Both the pairs of opposite sides parallel is a parallelogram. We know all this. These terms are familiar to us. I don't have to stress on it. No pair of opposite sides parallel, kite. One pair of opposite sides parallel, trapezium. Both the pairs of opposite sides parallel, parallelogram. So this is a kite. This so PQOR is a cyclic quadrilateral, as Hitesh told us. It's a kite because OQ is equal to OR radius and PQ is equal to PR. Tangents from an extended point of the circle are equal. So it's a kite. We need to find the area of the kite PQOR. So for that, we'll have to find the area of this triangle. Now, this is 90, right? This is also 90, correct? So this one is a right triangle. What's the formula? Half base into height, correct? Half base into, what's the radius? 5. Okay. And is this is what? Hypotenuse. 5√5 is the hypotenuse. But we need to find PQ. We'll have to find PQ because half base into height is half into base OQ into altitude PQ. The sides containing the right angle are the base and height, not the hypotenuse. The sides containing the right angle, OQ and PQ, base and height. So half into OQ into PQ. But do you know the length of PQ? No. Can we find it? Yes. How? Pythagoras theorem. So that way we'll find the area of the triangle POQ. The same will be the area of the other triangle POR. The same will be the area of the other triangle POR. So the area of the quadrilateral is the sum of the areas of the two triangles. Okay. That's what you see here. That's what you see here. See here. In triangle POQ by Pythagoras theorem, we found PQ is 10 centimeters. PQ is 10 centimeters. You can see how it has worked. This is the hypotenuse. This is the hypotenuse, OP. OP is a hypotenuse. So OP square, you can see here, OP square. PQ square, OQ square. PQ square, OQ square is equal to OP square. This is the hypotenuse. Then I've substituted. We don't know PQ. We don't know PQ. This is what we don't know. So you can see PQ square, 5 square and 5√5 whole square. So PQ square is equal to, this is 125 because 5√5 into 5√5. 5 5s are 25. √5 into √5 is 5. 25 into 5, 125. And this 5 square will be minus 25. Minus 25, which is 100. PQ square is equal to 100. So PQ is equal to square root of 100, which is 10. So half base into height, half into 5 into 10. So area of this one also, this is 25. This one is also 25. So the quadrilateral is 25 plus 25, 50. Correct, online children? What mistake we can make is taking 5√5 as the altitude. If you work the area like this, half into base 5 into altitude 5√5, you're wrong. Hypotenuse is not the altitude here. All right, children?
Yes, ma'am.
Okay, very good. We didn't do this in the last class? No, we didn't do this. Yeah, children. Find out what's the measure of POQ. I think we did a similar one in the last class. Yeah. Use alternate segment theorem and tell me which angle we can find. Does the chord PQ subtend an angle in the other segment, the alternate segment? No. Where does it subtend on the circumference? Okay, so last class, Kanishka wanted to know. She said, my teacher has not introduced alternate segment theorem. In that case, how do we do it? So in that case, this is what we'll have to do. So we'll do it without using alternate segment theorem. That's also easy. So now, what is the value of this angle, children? Oh, you already marked 90, so 90, sorry. How much is this one? This is 90. Why? Because radius, tangent, perpendicular to each other. So then how much is the rest of the angle, the remaining part? This one? 40. Then how much is this one? 40. Then how much is this one? 100. This is 100. This is 100. Now tell me here, if this is 70, you'll have to find QPT. You'll have to find this angle QPT, this one. This is 70. What is 100 minus 70? 110. So 110, this will be 55, this will be 55, right? Because isosceles triangle, OQ is equal to OP. OQ radius, OP radius, isosceles triangle. So the base angles are equal. 110 by 2, 55, 55. What's the measure of this full angle? Why? Because OP is a radius and there's a tangent. So this full thing is 90. But this portion is, how much we found? 55. 55, we just found this 55. So this will be 90 minus 55, which is 20. How much? 35. 30. Okay, I've done it using alternate segment theorem. Oh no, I've done it like this. Oh, okay, I've done it like this. Okay, I've just marked it X, X and worked it. So same method I've worked. You can go through the answer. Let me read it for you. So you can see I've marked it like this. X, I've marked it like this. So in the first figure, for the first figure, children, X plus Y is 90, correct? For the first figure, this one, X plus Y, this is X, this is Y, correct? X plus Y is for this figure. X plus Y is 90. X we don't know, plus 50, this is 50, is 90. So X is 40, correct? X is 40. Then I've written OP is equal to OQ radius. So then I've mentioned the two angles equal, which is X I've marked. Then angle sum property, X plus Z is equal to 180. Yeah. So like this, I've marked X, Y, Z and worked the answer. Okay, you can understand. See the next one. If the radius of the two circles are 6 centimeters and 10 centimeters respectively, find the lengths of the line segments AB and CD. AB and CD. Okay, now let's talk like this. Online students, what is the relationship between the line segment AB and the outer circle? Online students, what is the relationship between AB, the line segment AB and the outer circle?
Chord.
Chord. AB is a chord to the outer circle. And to the inner circle?
Tangent.
AB is a tangent. And the point of contact?
P.
P. Do we have a radius through P?
6 centimeters.
OP is a radius through P. OP is a radius through P. So 90 degrees. It's a right angle here. This is a right angle. The line segment AB for the outer circle is a chord. And for the inner circle is a tangent at P. And through P we have a radius. Through P we have the radius OP. PO 6 centimeters. And radius is perpendicular to the tangent at the point of contact. So 90 degrees there. Not because it's a chord, because it's a tangent. It's a tangent. OP and AB, radius tangent. Okay, now what is AB to the outer circle? It's a chord. And what do you know? The perpendicular from the center to the chord bisects the chord. Or you'll have to prove that the two triangles are congruent to each other. That's all. If you don't remember that theorem, you can prove that these two triangles are congruent to each other. Therefore, AP is equal to BP. But you don't have to do that. Just write the perpendicular from the center to the chord bisects the chord. So that means AP is equal to BP. So can you find AP using Pythagoras theorem? So double it, you will get AB, right? Double it, you will get AB. So we found AB. How do we find CD? Oh, that's some other.
If we put accepting radius of 10 circles,
Okay. The radius is 6. Wait, 1 minute. 1 minute, 1 minute. This is 6. Okay. Then? It is 10. So yeah. The same will be. But what is the theorem? Perfect. What is the theorem we have learned last year, 9th standard? Chords that are equidistant from the center are equal. Chords that are equidistant from the center are equal. Equal chords are equidistant from the center. Equal chords are equidistant from the center. Chords that are equidistant from the center are equal. So now these two are equal chords because they're equidistant from the center. How? Because what? See here, PO. This is the distance of the chord. This is the distance of the chord AB from the center, 6 radius. What is the distance of the other chord? OQ. And how much is that? That's also 6 centimeters. Because distance is always the perpendicular distance. Distance is the perpendicular distance. What is the perpendicular? Are you listening? Meaning following? What is the perpendicular distance of the chord CD from the center? OQ. OQ is the perpendicular distance. Why is it right angle there? Because radius perpendicular to tangent. So what is the perpendicular distance? Radius only 6 centimeters. So OP is the distance of AB from the center. OQ is the distance of CD from the center. And OP is equal to OQ because radius. That means the length of AB will be equal to the length of CD. The length of AB will be equal to the length of CD. Equal chords that are equidistant from the center are equal. Yeah. So in AOP by Pythagoras theorem, so you get AP is 8 centimeters. So AB will be 2 into 18, 16. So CD is also 16 because chords of a circle equidistant from the center are equal. Chords of a circle equidistant from the center are equal. The chords are equal. So CD is also 16 centimeters. Yeah, the chord of a circle of radius 10 centimeters subtends a right angle at its center. The chord of a circle of radius 10 centimeters subtends a right angle at center. See, actually the answer you know, but if you should not make the figure. So the chord of a circle, chord of a circle of radius 10 centimeters. We'll mark that later. The chord subtends a right angle at its center. Meaning take the center. Let's name the chord AB. How do you identify the angle subtended by this chord at the center? Join the ends of the chord to O. Join A to O and B to O. This is the angle subtended by the chord AB at the center. Join the ends of the chord to the center. A to O, B to O. So this is the angle subtended by the chord AB at the center. And it subtends a right angle. So this is 90 degrees. What is the radius? 10 centimeters. Now how will you find AB? Pythagoras theorem. That's all. That is the length of the chord. That's the length of the chord. All right. Yeah. Tell me the answer for this. You're talking to yourself. I can't hear you. Louder. Yes. What's answer finally? 9. Correct. Correct. Yes, somebody wanted to say something? Online students? What's the answer? What's the length of the line segment BC? Oh, yeah, 11 minus 4 is 11 minus 4 is 7. Yeah, okay.
Ma'am.
10. How many of you say 10? Online students?
10.
10. Subbalakshmi.
10, ma'am.
10. Rajeshwari. All right. Yeah, it is 10 because since this is 4, this will be 4. This will be 4. So this remaining portion will be 11 minus 4, which is 7. So if this is 7, this is 7. And since this is 3, this one will be 3. So BC is 3 plus 7, 10 centimeters. Okay. So how do you present the answer? Tangents drawn from an external point is circle are equal. Okay, so AR is equal to AQ. So that means AQ is equal to 4 centimeters. Then AQ plus QC is equal to 11. AQ plus QC is equal to 11. 4 plus QC is equal to 11. So QC is equal to 7. Now QC is equal to PC or CP, whatever. QC is equal to CP. So therefore, CP is equal to 7 centimeters. Now this side you have BR is equal to BP. So BP is equal to 3 centimeters. So now BC is equal to BP plus PC. BP is 3 plus PC is 7, yeah, 7, 10 centimeters. So this is how you should present it. So okay, online students, what are the equations? Tell me quickly. Tell me the 3 equations. What are the 3 equations you can frame from this figure and the information given here?
Ma'am, x plus y equal to 14. X plus z equal to 12. Y plus z equal to 8.
Correct. Right? X plus y is equal to 14. Y plus z is equal to 8. Then x plus z is equal to 12. So you have 3 equations. Then you'll have to add the 3 equations. Take out 2 common. We have done this, no? Okay, if x is given, if x, y, z they are given, you don't have to mark, meaning it's if it's marked and if it is not marked, I've written that tangents from an external point of the circle. If it is not marked, then you'll have to write tangents from an external point of the circle are equal. So AD is equal to AF is equal to X. Say means let. Say means let. Don't we say, say you have X chocolates like that. Let us say. If X, Y, Z, they are not marked, then you should write this part. If it is already marked, then you can start from here. Okay, so you can see your A, B, you can, I'll not disturb you. These are given to you. That means this, that means these are the 3 equations. Adding the three equations, taking 2 common, and then x plus y we know is 14. Substituting, you can get z. Go through, children. It's easy. Then once you get z, put z here, put z here. You'll get y. And when you put z here, you'll get x. That's what I've written, using 3. That means using 3 meaning this one. Using 3, x is equal to 9. When you use 3 and substitute z is 3 here, you will get x. And then using 2, you will get y is equal to 5. So the question is to find AD, BE and CF. So AD is x, BE is y, and CF is z. CF is z. We have to find x, y, z. Sorry, we have to find AD, BE, CF, which is x, y, and z. What can you join here? Join. When can we use trigonometry? When we have right triangles. Okay, trigonometry, when we have a right triangle. Okay, fine. Now we don't have a right triangle here. So we'll make right triangles. So for that, we need to join what? Join OP and OQ. Join OP and OQ. Fine. Let's join OP and OQ. Join OP, join OQ. Now, radius perpendicular to tangent. So there's 90 here and 90 here, correct? So that means OPR is a right triangle. This one is a right triangle. This one is a right triangle. What is this full angle? What's the measure of this full angle? 120. So how much is it? To erase the whole thing. 1 minute. I'll not show both. How much is this, children? 60. This one, 60. And this 90 because radius perpendicular to tangent. All right, so join construction, join OP and OQ. Now, OP is perpendicular to the tangent. PR, correct? PR is a tangent, correct? PR or RP, RP. Therefore, angle OPR is equal to 90 degrees, correct? So in right triangle OPR, now connect, now see the sides, now which ratio to use? What is given here? OR, PR, RQ. They want you to connect OR, PR and RQ, which is OR, this is OR, which is PR, this is PR. RQ is here, so leave that. So that means you'll have to connect OR and PR, correct? See, trigonometric ratio, you can take one angle and 2 sides only. You cannot take 3 sides. So which are the sides of this triangle? Only OR and PR. Okay, so in right triangle OPR, which is the ratio you should use to connect OR and PR? To connect OR and PR, which is the hypotenuse. OR is the hypotenuse. You'll have to connect the hypotenuse and PR. What is PR for 60 degrees? Adjacent side. PR for 60 degrees is adjacent side. Which is the opposite side for 60 degrees? OP. OP is the opposite side for 60 degrees. And PR is the adjacent side for 60 degrees. So clearly you'll have to connect PR and OR, which is the hypotenuse. Adjacent side and hypotenuse. So what is it? Cos or secant. Cos 60 or secant 60. So we have to take cos 60 or secant 60 degrees. So cos anything, cos 60 degrees is equal to adjacent PR by the hypotenuse OR. What's the value of cos 60? 1 by 2. Cos 60 is 1 by 2 is equal to PR by OR. So when you cross multiply, you get OR is equal to twice PR, correct? And is PR equal to PQ? Is RP equal to RQ? RP, RQ. Because what's the reason, online students, why is RP equal to RQ?
Length of the tangent drawn from an external point.
Correct. The lengths of the tangent drawn from an external point of the circle are equal. So RP is equal to RQ. So now what we can do is OR is equal to twice PR, meaning PR plus PR, correct? Twice PR is PR plus PR. So OR is equal to PR plus RQ. RQ. So just join, get right triangles. Sorry, join, get triangles. And using the theorem radius perpendicular to tangent, you get right triangles. Take any one of the two right triangles. Any one you can take. And use the appropriate ratio. Now, how to decide? We have three ratios. Which one to use? So look at the sides. Look at the sides. Which sides you have to connect? So if you take this triangle, if you take this triangle, which are the sides? OR and PR. OR and PR. Now for the 60 degrees, PR is the adjacent side and OR is the hypotenuse. So we have to take cos. Cos 60 is equal to adjacent by hypotenuse. Substitute, cross multiply, you get a result. But that's not the required result. What you get is not the required result. So what to do? Write twice PR as PR plus PR. And we know that PR is equal to RQ. So write this as R. That's what is here. Yeah, tell me, children, anybody can answer? Online, offline, anybody can answer? Yeah. Loud, loud.
And external point A.
Hmm.
So A is equal to EC. And same we have EB is equal to ED. Then we have to mark it 1 and
No, just add both.
AB is equal to A plus E.
No, add this. What is add?
AB is equal to
No, right? AE plus EB is equal to EC plus.
E.
What is AE plus EB?
AB
Is equal to EC plus ED? CD. Very good. Correct. Because E is the external point to both the circles. E is an external point to both the circles. So EA is equal to EC from one circle and ED is equal to EB for the other circle. Correct? So tangents from an external point to the circle are equal. Just write that and add both. You get the required result. Which school has finished all the portions? Done. Kamlani Ketan, all portions over. Full. Oh, okay. No, because this presentation, this presentation is going to come to an end now. Then online students, Rajeshwari, Meera, learned all the chapters in school.
Yes, ma'am.
Yes.
Tashmi? What about Priyasha? Okay, Sashmin, yes, ma'am. All right. Priyasha?
Yes, ma'am. What is it?
Very nice. All right. Yeah. Find A, children. Look at this figure. From this figure, find A. Sorry. Oh, it's not clear, right? Yeah, yeah. 30. You got the answer. 1 second, 1 second. Just a second, children. Thirty. 32. How many of you said 32?
See.
Oh, that's what I'm wondering. Okay, okay, yeah, yeah. No, I was like, no, I hadn't found out in that speed actually. So I was like wondering how suddenly these people say 32. So you mistook it to be a triangle, not a triangle. So they thought it's a triangle. So 90 degrees, 58 degrees. So angle some property, 32 degrees. Not a triangle. What Kanishka, are you thinking or no? Okay. Found the value of you, found the value of A, online students? What's answer? 46. Louder, darling. 161. Okay. Yes. What is the value?
42.
Meera, once again, Meera. Meera, once again.
Ma'am, 42.
42. Okay, we'll see. I don't know.
Ma'am,
61
degrees.
Okay, Meera 42. 1 minute. Let me make a note. Meera says 42. Then here, Harani and Rajarajeshwari, they say 61. Then who? Hitesh also 61. Hitesh. Yes. Any other answer? Yes, Priyasha. Priyasha, Lakshmi, Tashmi, Rajarajeshwari. Okay. Answer these questions. Let me see. First steps. These are the steps to find the answer. Step one. Step one. Angle ABT is equal to what? Find this. I want the measure of angle ABT. 29.
29 degrees.
29. 29. Because, okay,
20.
1 minute. Yeah, 1 minute. Let me put it like this. Step one. Step one. Angle, what is that called? AOQ is equal to twice angle ABQ, correct? Which is the arc here? Which is the arc? AQ is the arc. Arc, see the arc is AQ. AOQ, ABQ. So AQ is the arc. AQ is the arc. AOQ is the angle at the center. ABQ is the angle on the circumference. And what is the relationship? AOQ will be double, twice of angle ABQ. Center is double the circumference angle. They should be made by the same arc. From the name itself, you can make out. Name the angles, you can make out AOQ, ABQ. So how much is AOQ? 58 is equal to 2 times ABQ. So angle ABQ is equal to 58 by 2, 29 degrees. 29 degrees. So this angle, this one is 29 degrees. Now in triangle BAT, A is an angle, right? A is an angle of, actually we are struck, if you don't have to tell me, but if we must have been struck with a quadrilateral OATQ, we must have been looking at angle A as an angle in the quadrilateral and not an angle in the triangle. Maybe. So we may have got caught there, thinking of A as an angle in the quadrilateral only, OATQ, and not in the triangle. A is an angle of the quadrilateral as well as the triangle. A is an angle of the quadrilateral OATQ. OATQ is a quadrilateral. A is an angle of the quadrilateral. OATQ, this one. Now see here, don't say TA is equal to TQ. Correct? Is TA equal to TQ? No, TQ, see, if you produce it, it will go inside the circle. It's not a tangent. It's not a tangent. Okay. So when you work this, you get ABQ is 29. And in the triangle BAT, A is an angle. A is an angle. This is 90 degrees. This is 90 degrees, which is 90. This is 90. And this is 29. So find this angle using angle sum property. So you first find ABQ, this one, by this theorem, which you have learned in standard 9. Then you find this angle, 90 degrees. Then in the triangle, angle sum property. So somebody said 61. Who said 61? Hitesh. And you also said 61. How did you find it? Like this only. Very good. Yeah. Yeah, I wanted you can go through this and understand and write down. There's nothing difficult in this. I worked this. All of you work this in the class now. All of you take down this question and work this now in your notebook. It's simply using Pythagoras theorem, similar triangles, proportion. Online students, are you working?
Completed.
Yes, ma'am.
Completed. Okay. Meera, Sashmin, Priyasha?
Completed, ma'am.
Yes, ma'am.
All right. And Amit? Done, children? Yes. All right. So how many right angles can you mark here? One is angle in a semicircle is a right angle because AB is a diameter. AB is a diameter because it passes through the center O. So since this is the diameter, see here, E is a point on the circumference of the outer circle. E is a point on the circumference of the outer circle. See at the ends of the diameter, join B to E, the ends of the diameter, A to E. This is a right angle. Angle in a semicircle is a right angle. Okay. And then the other thing, BE is a tangent to the inner circle. BE is a tangent to the inner circle at D. DO is the radius. So it's 90 here, radius and tangent perpendicular to each other, 90 degrees. So like this we have two right triangles. Oh, one second. Sorry, children. So see here, ODB is 90 degrees. ODB is 90 degrees because radius perpendicular to tangent, and then Pythagoras theorem, you can find BD. Then, okay, 1 minute. The other right angle, 90 degrees here, 90 degrees here, because angle in a semicircle is a right angle. And then we have proved similarity between these two right triangles, BOD and that is the small triangle, and this big triangle. See here. There's a triangle. There is one big triangle like this. And then there is another small triangle like this. This is B, this is D, this is E, this is O, and this is A. Correct? Here, if I draw it again, please watch this. There is one right triangle. What is that one right triangle called? It's called AEB. AE. Okay, so there is one right triangle which is called A, E, and B. Then you can see this one, OD here, O and D. This is also 90 degrees. So we can see two right triangles, BDO and DEA. So those two right triangles. How do you prove that? You can see two right triangles. This is the small one, OBD, and the big one, ABE. So in these two triangles, this is the common angle. Angle B is the common angle. And then 90 degrees in the small triangle, 90 degrees in the big triangle. So the two triangles are similar to each other, correct? And how do you name the triangle? See the order, AA similarity, they are similar. B goes with B, so you can see here. B goes with B. Then D is 90, E is 90. So you can see here, D is 90, E is 90, the third place. And then O and A, the third vertex. They're similar. If they're similar, their corresponding sides are proportional. So write the proportion, substitute the values, and you get some information. And then again, Pythagoras theorem in the other right triangle AEB. That order you should understand what to find next. But the same sum I'll give you as a test in some class. I don't know when. Should be able to do it. So whenever you see a diameter, angle in a semicircle is a right angle. Radius and tangent 90 degrees. All of you finished? Okay, do this one. Find PR. Class, work this. Tell me the length of the line segment PR. From the figure, find PR. $20. Perfect. Children, so in future, I'll not be mentioning class at the center. If I say there is a class, it is a physical class only. Online students will take it online. Otherwise, there will always be physical class. If I'm not, if supposing the weather, it's raining badly and it's difficult to come. In that case, I'll specify online class today. Online class only today. I'll specify online class only today. Okay. Whatever, then it's only online. If I say only online, it's only online. If I simply say class, it is at the center only. Yeah. Yes.
Ma'am, 26 centimeter.
Perfect. Meera, very good. 26 is the right answer. Here also, who's got it? Sneha got 26. Harini has got 26.
Ma'am, I too got
Tarun
26
Murali, no, I forgot. Tarun Murali got 26. Rajeshwari also, is it?
I too got 26.
Yes, ma'am.
Lakshmi also got 26.
Yes, ma'am.
Rajeshwari got 26. Very good. Lakshmi, tell us how to do this.
By Pythagoras theorem, we have to find OP and
Okay.
RO1, O dash.
And now
R.
in this triangle, okay, in triangle POQ, which is a right angle?
Right angle at Q,
At Q. So OP is the
hypotenuse,
hypotenuse. What's the length of the hypotenuse by Pythagoras theorem?
5 centimeter.
5. Next,
Next triangle, right angle it has S, and hypotenuse is 13 centimeter.
which is the hypotenuse?
R O dash.
O dash R or R O dash. And that is 13. Very good. Then,
Radius now 3 and 5.
correct. So this is the radius. From here to here is the radius, 3 centimeters. Then from here to here is the radius, 5 centimeters. From here to here is the radius. Very good. So PR is equal to 5 plus 3 plus 5 plus 13. Very good, children. All those who got the answer 26. The others hope. It's easy for others also. It's not difficult. Just that we couldn't get it now, but it's easy. So first radius, tangent, perpendicular, so 90 degrees. Both are right triangles. Pythagoras theorem. This is 5 and this is 13. And this one is nothing but the radius. This is the radius. Center to circumference, the radius, 3 centimeters. Again, center to circumference, this is the radius, 5 centimeters. So 5 plus 3 plus 5 plus 13 is PR. That's what is here also. All right. I'll share these pictures later. Oh, sorry, I don't know if I did it in a hurry. Anybody wants to see? You can have a look at the answer if you want. All right, children. So we're going to take a test now. Let's see, you learned all the chapters in school. Which chapter is it? Okay, tell me on which chapter you want to test. I'll see if I have a paper on that. Trigonometry? Trigonometry? Okay. Desh is excited. Where's trigonometry? Yeah. Yeah, start working. And in real numbers, what part of real numbers is completed, children? Real numbers, only that first exercise. Huh? Give me your textbook. No? One. Anybody has Candy? NCRT? Yeah, tell me what's done in your school from real numbers. Only? Okay, only that. LCM, HCF, then? Huh? Sorry? That's not there. Okay. Euclid's division lemma is not there. Okay. Only the numerical stuff. LCM, HCF, word problems and all that, right? Root 2 is irrational, root 3 irrational and stuff like that. Then that's all, right? Nothing else has been done. The next class we'll do real numbers then. That is tomorrow we have a class? No. Wednesday. Wednesday we'll do real numbers. Yes, children, once you're done, yeah, please start working. Tell me the value of sine 15 and cos 15. Test trigonometry. First question. Work and tell me the value of sine 15 and cos 15. Yes, Nana? Method is? Deleted, huh? But this one is not complementary. No, this one is not complementary. Yeah, in trigonometry. Oh. You'll have a tough time in 11th standard. I don't know why they've made that. They could have taken off real numbers. Real numbers is not needed. Then there are some chapters which are okay, like arithmetic progressions. Even if you don't learn, you can still manage in 11th standard. Trigonometry, without trigonometry, next year, how will you manage? Yeah, trigonometry, the teacher should have taught you in full. Even if it's not important for the boards, it's a continuation. If you take maths in 11th standard, what will the teacher in 11th standard tell you? This you've already learned in 10th. But will we gather the guts to tell her, no, this was deleted in 10th standard, so you teach us again? No. We'll just look at our friend's face and leave it like that. Yeah, good. That's the best thing. Because it's a continuation, 11th standard. Like ABCD for first and second, the trigonometry is ABCD for 11th and 12th. So, and this is not complementary ratios. Yeah, anyone online got the answer?
And sine 15 is root 3 minus 1 by 2 root 2.
Sine 15 is root 3 minus 1 by 2 root 2.
Yes, ma'am.
No, but I have a different answer. Root 3 minus 1. No, I have a different answer.
I'll try it out again, ma'am.
So funny, Tarun. It's okay, you can laugh. What do you have at school tomorrow? Exam? Sure, which subject? Science. How was the paper today, math paper? Share the paper with me. No idea, children. Let's not waste time. No idea. No idea. Online students? Rajeshwari? Class, use the emoji, raise your hand. Online students? Very good. All right. Answer for this one? Anybody online? No. Okay. All right. See here. There is a formula given to you. There is a trigonometric formula given to you. See here. Sine of A minus B is equal to, like you have an algebraic identity. A plus B the whole square is equal to A square plus 2AB plus B square. I think you both, are you getting distracted? No, right? Yeah, sine of A minus B is equal to, okay, like A plus B the whole square is equal to A square plus 2AB plus B square. Just present it. So like that, you have a trigonometric formula here. Sine of A minus B is equal to sine A cos B minus cos A sine B. This formula is given to you. Using this formula, you should find sine 15. Now, how can you express 15? 60 minus 45 is 15? 60 minus 45 is 15? Or 45 minus 30 is 15? Why are we taking only these angles? Because these are standard angles. You cannot say 100 minus 85 is 15 because we're talking about standard angles. 0, 30, 45, 60, 90. So you can take 60 and 45 or 45 and 30. Okay, so let A be whatever you want. Okay, so let A be 45 degrees or whatever you want, whichever two angles you want. So A is let A be 45 degrees and B be 30 degrees. So sine of A minus B, A is 45, B is 30 is equal to sine A, sine 45, cos B, cos 30 minus cos A, cos 45, sine B, sine 30. Now what is 45 minus 30? 15. So sine 15 degrees is equal to, what's the value of sine 45? 1 by root 2. Cos 30? Cos 30. Root 3 by 2 minus cos 45? 1 by root 2. Sine 30? 1 by 2. So what is this? Root 3 by 2 root 2 minus 1 by 2 root 2. So that is, oh, Amira, I think you said root 3 minus 1 by 2 root 2 before rationalizing the denominator. I saw my answer where the denominator is rationalized. Maybe that's why I said I have a different answer. You're right. You said root 3 minus 1 by 2 root 2, right, Meera?
Ma'am, it was my answer, ma'am. Priyasha.
Priyasha, I'm so sorry, Priyasha. I'm so sorry. So
That's
I just looked at the answer because I didn't want the others to, meaning I didn't want the class to see the answers. So I quickly looked at it. It was root 6 minus root 2. I didn't notice the denominator. So I thought you were wrong. I'm so sorry. Yeah. So now this is root 3 minus 1 by 2 root 2. Correct? Now the denominator is irrational. So we need to rationalize the denominator. So into root 2 by root 2. You don't have to multiply by 2 root 2. Root 2 is enough. So that is equal to root 6 minus root 2 by 4. In the same way, you'll have to find cos 15 using the cos formula. To find cos 15, you should use the other formula which is given to you. Cos of A minus B is equal to cos A cos B plus sin A sin B. You should use that formula and find cos 15. Again, there you should take A as, you take A as 60 here. It's okay. Not that you should take 45, 30 only. You take 60 and 45. You get the same answer. All right. Work, all of you. So this is not complementary ratios. This is not complementary ratios. This is using standard angles. And we have done the same sum in the class. The same sum, not a similar one. We have done the same in the class. And I cannot be happy for that. Done? All right. So for sine 15 degrees, you should use a sine formula given to you. You must use this one to find the value of sine 15 degrees. And you must use this one to find the value of cos 15 degrees. All right. Next one. Yeah. No, let me not say all the other t ratios. Find only. Okay. Without using a right triangle. Okay. Without using a right triangle, find the value of. Find the value of. You should not use a right triangle. Find secant theta. Without using a right triangle, find the value of secant theta. Given tan theta, find the value of secant theta. Got it? Yeah, what's answer? Give me a book. First. LCM, you should take the LCM and what have you written? 4 and by whole square is there. No, you don't apply the whole square for the denominator. Huh? Whole square you should write. All right, so Hitesh has worked it correctly. What about the online students? Meera, Rajeshwari, Lakshmi, Sashmin, and Priyasha. Shall we do it together then? We'll not waste time. Shall we do it together? Yes or no?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Yeah. All right, children. Yeah, thank you. See you. We'll do it together. See you. Without using a right triangle, please use a trigonometric identity. What is which is the identity that connects tan and secant?
Secant square minus tan square equal to 1.
Secant square theta minus tan square theta is equal to 1. First, write that. We need to write that first. Secant square theta minus tan square theta is equal to 1. All right, now we need to find secant theta. So you can substitute here itself, or you can also write like the secant square theta is equal to 1 plus tan square theta after transposing. So secant theta is equal to square root of 1 plus tan square theta. So secant theta is equal to square root of 1 plus 2mn by m square minus n square the whole square. So secant theta is equal to square root of 1 plus 4m square n square divided by m square minus n square the whole square. All right, so secant theta is equal to common denominator now. Secant theta is equal to square root of secant theta is equal to square root of what's LCM? No, from the board. What's LCM? So don't expand that. M square minus n square the whole square. Don't expand that. So what will you get here in the numerator? Whole square. Now, children, please recall the identity here. Please. Numerator looks like what? A minus b the whole square. What is this? You people have to remember. How many times? I've told you many a times. Then, children, I'm so disappointed. Every time, you have never recalled this identity for me. Every time we come across a situation, see, these identities are so useful. A plus b the whole square minus a minus b the whole square is equal to what? 4ab. Then by transposing, what are the other things you get? A plus b the whole square is equal to a minus b the whole square plus 4ab. Then what's the other one? A minus b the whole square is equal to a plus b the whole square minus 4ab. Then what's the other identity? This is one thing. What's the other one? A plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square, right? All of you. Write down these identities, all of you, please. They're so important. Yeah, now this is of the form. This is of the form a minus b the whole square plus 4ab. See there, a, what is a? A is this one. This is a minus, this is b the whole square plus 4. This is a, b, 4ab. What is a minus b the whole square plus 4ab? A plus b the whole square. A plus b the whole square. Don't expand this. Write the denominator as it is. Do not expand the denominator because it's under the square root. Is equal to square root of, what is this? A plus b whole square divided by m square minus n square the whole square. Now come out of the square root. So it will be m square plus n square divided by m square minus n square. Yes or no, children? Yeah. This is not complementary ratios. Yeah. So given tan theta, if you have to find secant theta, use the identity. Use the identity, substitute, then LCM and all that. Don't expand when you're under the square root and you have m square minus n square, the whole square. Don't expand. It's a perfect square. So you can just come out of the square root. And the identity you have to recall. That's all. Online students, any doubts, any questions here?
No, ma'am.
Okay. Others, all of you, please acknowledge. Understood?
No, ma'am. Yes, ma'am.
3 voices I heard. 2 more voices. Sashmin, are you there? Give me your book. Pass me. Why you haven't started working this? Why you haven't started working this? What were you doing all the while? No, you have to answer. Put your hand down. Yeah. What was your reason? Just tell me. Louder. Why? You're lazy to write that name. All of you are writing? So what's the value of cos theta, class? Cos theta? Reciprocal of secant theta, m square minus n square by m square plus n square. Reciprocal of secant theta is cos theta. Cos theta, supposing they ask you to find secant theta and cos theta. You found secant theta. So cos theta is the reciprocal of secant theta. M square minus n square by m square plus n square. So here I've used the right triangle. I told you not to use the right triangle, but you can work using the right triangle. So that answer I have here, I'll show you. Yeah. Yeah, class, go through the working here. So you should draw the right triangle. You know that, no? Tan theta means opposite by adjacent. Tan theta is opposite by adjacent. So I have marked this one as theta. I have marked this as theta. So this is the opposite side. I have marked 2mn here. And this is the adjacent side. So I've marked m square minus n square. This is opposite. This is adjacent. Correct? So using this, you should find the hypotenuse first. First, find the hypotenuse using Pythagoras theorem. So BC square is equal to AC square plus AB square. Use this and find the hypotenuse using Pythagoras theorem. So you see here, AC square is m square minus n square the whole square plus AB square 2mn the whole square. So you get m square minus n square the whole square plus 4m square n square. Again, identity. See, using the identity, a minus b the whole square plus 4ab is a plus b the whole square. So this one is nothing but a plus b the whole square. M square plus n square the whole square. So BC is equal to m square plus n square. Now we found BC. What is BC? M square plus n square. Now find all the ratios. Sine theta, cosecant. Sine meaning reciprocal is cosecant. Cos of the reciprocal is secant, and then cot. Cot you can find using this itself. Cot is reciprocal of this. See, now in the exam, be careful. Read the question properly. If they say if tan theta is this, find cot theta. You don't have to work anything. What is cot theta? Cot theta is straight away m square minus n square by 2mn. So here also you can see we use the identity here. All right, children. I'll share this picture on WhatsApp if you want to go through it. You understand the procedure, right? All of you? Okay, I've given the alternate method also using the identities. I've also given the alternate method using the identities. I'll share the picture. Yeah. Yes, children, please mark this one. Please mark this. I'm going to teach like that. 2 minus root 5. No. Two minus 1 minus 2 root 2. No. Online students? What you didn't see? If tan is 2, without that you answer the question.
I thought multiplication.
You thought what?
It's multiplication.
Sin is ah.
Like sin is, I thought it's tan is. I didn't see that.
Oh, okay, okay. Yes, what's happening, online students? Rajeshwari, are you there?
Yes, ma'am.
Okay. Lakshmi, are you there?
Yes, ma'am.
Meera,
Yes, ma'am.
Tashmeen, text me. Priyasha,
Yes, ma'am.
all right. Okay, Sashmin, yes, all right. Good, good. Yeah, 8 minus root 5 by 2. Correct. Got it? Very good. Have you all used a right triangle like this? That's all. Tan A. Tan A is equal to 2. That means opposite by adjacent is 2. Use a right triangle. Take the values in the right hand. 2 means 2 by 1. 2 means 2 by 1. Tan A is equal to 2 by 1. You know how to mark that, no? The right triangle. This is A. Opposite 2. Adjacent 1. Then find the hypotenuse using Pythagoras theorem. Root 5. Then find the values of sin A, secant A, tan A, and cosecant A. And then evaluate. And then substitute the values and evaluate. Yeah, write down, children. See, if you have any questions you don't understand anywhere, please ask me. Please ask me. Finish writing? Shreya? Finished? Have you written? Priyanka? Okay. No, I trust you. Finish writing, students, online?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Okay.
Yes.
All right. Very good, very good. Okay. Yeah, we'll do this and stop for today. Yeah. No, see, it's just 1 minute. If you know how to do it, it's just 1 minute. Thirty, 30, 60, is it? We'll see, yeah. Same thing, 30, 30, 60. Yeah? Tell me the order A, B, C.
60,
tell me,
30,
no.
0. ABC.
60,
Ma'am,
30,
A-
0.
30 and 0.
A
Yes,
is
ma'am.
equal to
C
60.
is 0.
No, one by one. Priyasha, tell me your answers.
A is 60, B is 30, and C is 0.
Okay, 60, 30, 0. Yeah, I think Meera also wanted to say.
Ma'am, A is equal to 60, B is equal to 30,
Lakshmi.
C is equal to 0. Yes, ma'am.
Same, huh? Same, is it Lakshmi? 60, 30, 0, right?
Yes, ma'am.
Okay. So here also in the class, Tarun has got 60, 30, 0. Hitesh has also got 60, 30, 0. Very good. Harini? Oh, you're getting the angles, but not A60 and C0. Okay. Now quickly, let's see how easy this is. See, if you know the idea, it is easy. I'm not saying from a teacher point of view. I'm a student here. From student's angle, if you know how to do this, it's just a minute's job. See here. So what is what is given? Sine of A plus B plus C is equal to 1. When is it 1 in the sign table? Sign 90 is 1, correct? So immediately, won't you write it fast if you know it? So what is A plus B plus C? 90, correct? So then what is tan A minus B? 1 by root 3 is tan 30. So tan 30. So that means A minus B, sorry. That means A minus B is equal to 30. Then what's the other one? Secant of A plus C. Secant A plus C is equal to 2. When is it 2 in the secant table? 60. Because cos 60 is what? 1 by 2. So secant 60 is 2. So secant A plus C. Oh, sorry. So A plus C is equal to 60. Now see, A plus C is 60. No, this A plus C is 60. So 60 plus B is equal to 90, correct? So B is equal to 30. Got it? Isn't it easy? If you know that you had to do it like this, isn't it easy? You can do it so fast. It's just 1 minute work. Now we got B. Now B is 30. Now come here. A minus. So come here and A minus B is 30. 30 is equal to 30. So yeah, oh, A 60, sorry, A 60. So here now if you come here, A 60. So 60 plus C is equal to 60. So C is equal to 0. Now it's only substitution. Yeah, so you can see the answer here. Go through the answer, children. I'll share the images of today's class on WhatsApp. Just go through the answers. You can see here. You should write 1 as sine 90. Write 1 as sine 90. And when you compare both the sides, you get A plus B plus C is 90. Tan 1 by root 3 should be written as tan 30. So A minus B is 30. Maybe I worked it in a different way, like substituted and all that, but you can do it anyways, like what I told you now also. Then 2 secant 60. So A plus C is 60. You can do it after getting the equations, you can do it the way I told you now. A plus B plus C is equal to 90. And we got A plus C 60. You do it like that. I've done a different method here. You can use this method. A plus C 60. So 60 plus B is equal to 90. So B is 30. Like this you can work. I'll correct this slide. This is also fine. I've done it in a lengthy way. So I'll correct this slide and share it with you. Understood, online students?
Yes, ma'am.
Yes,
All
ma'am.
right. All right, children, I'll share all the pictures on WhatsApp today. All right, so that's it for today's session. Thank you so much. You may leave the call, children.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, children.
Thank